Welcome to the Artemis project. I am Franco Nicolucci, scientific coordinator of Artemis, and I will present in this video the purpose and the goal of the Artemis project, and why we hope it will be an important factor helping the conservation and preservation of cultural heritage assets. So the objective of the Artemis project is to unlock the potential of a full-fledged digital approach and contribute with digital means to research and practice in conservation and restoration of cultural heritage. We will avail of advanced digital models called digital twins to replace physical operations on the heritage assets, because we will propose to adopt instead digital activities to check the effects before operating directly on the heritage assets. The project addresses the work of professionals in conservation and restoration, and also of researchers in heritage science, supporting decisions and open new opportunities to valorize and preserve fragile cultural heritage assets. So the first point we want to consider is how we will manage digital information of cultural heritage. And we will adopt the concept of heritage digital twin. What is a digital twin? It is composed of three components. The real world entity, for example, a monument, which we call a physical twin, and its digital representation, the actual digital twin, which is created in such a way to be able to mirror the physical counterpart. So all the details of the physical twin will be reproduced in a digital way in its digital twin. How this works is called the linking mechanism. So there is a continuous flow of data between the two, which enables the continuous update of the digital twin on the changes on the physical twin, and enables to simulate its behavior and what is happening on its features. For this, we will use measurements of the physical features and other digital information stored in our records, like historical information, architectural information, and so on. The specific digital twin we are going to use for this purpose is called the heritage digital twin. This can be defined as the holistic complex of information about the heritage asset. This means that all the information is included, not only the physical aspects, but also intangible aspects, historical information, and so on. For this, we will create a digital twin, which is an extension of the documentation standard, well-known documentation standard, the CRM. So all the existing data will be interoperable with our digital twin and can be used to improve its content and reuse the existing information, which is stored and organized according to this international standard, which in practice is adopted almost everywhere. If necessary, we can extend the data model, the heritage digital twin, and the Artemis project actually uses such an extension, which is called the reactive heritage digital twin, in short RHDT. Let us explain this in an example, the famous Cathedral of Florence, which has a very large documentation, text, images, 3D models, and so on. All the information is somehow linked to some other information, and of course to the main assets, the cathedral. For example, a book was written by a person, a photo concerns a detail of the cathedral, and so on. So there are relationships between different pieces of information which will be stored in our heritage digital twin. Some parts of the asset, for example, the famous dome by Brunelleschi, is an asset on its own, so it may be considered separately, although being part of the main digital twin, and it will have its specific digital twin. To show an example of intangible components, we can quote the carriage blow up, which is an event which is some 600 years old. This event takes place on the Holy Saturday, the day before Easter, and the carriage is carried in front of the cathedral, escorted by guards in Renaissance costumes, which is called the historical procession of the Republic of Florence, and is also an intangible heritage component on its own. And a rocket is lit in the cathedral by the Archbishop. It reaches the carriage and fires the fireworks which are put on it, and so the carriage blows up. This is considered a good omen, and in general for the town and for its citizens. And the information about this event will also be included in the digital twin of the Florence Cathedral. So here is a more detailed explanation. The cathedral is documented in documents, text documents, which are part of the digital representation, which also includes digital visual objects, the photo you have seen in the previous slide, 3D models like the one you see on the right, and possibly more. For example, the results of scientific analysis of many different kinds, on the paintings, on the structure, on conservation activities, and so on. There are relationships among the parts of this documentation. For example, this report was authored by somebody, and so there is a sort of cobweb which connects all the digital twin components which are related to the same heritage asset. So you can see here in the image 2 examples of such cobwebs, of such a set of relevant information whose parts are linked to each other, which are titled HDT1 for a monument and HDT2 for another monument. If we consider the assemblage of all the digital twins which we are taking into account, we obtain what is called a semantic graph. And such semantic graph, here there are only 2, but maybe there are thousands or even millions of these digital twins. It can be explored very efficiently using appropriate software, for example, the one which is called the GraphDB. The information complex of the semantic graph and of the data it refers to is called a knowledge base. And for Artemis, the semantic graph will be stored in the project cloud. Actually, only the metadata will be stored in the project cloud, and the actual data to which the metadata refer will be kept distributed wherever they are and maintained by their creators, by their owners. How are we going to create such a system? Okay, we will first take into account the many repositories of heritage-related data and their individual metadata organizations called schemas. They may be distributed everywhere in Europe, maybe everywhere in the world. Uh, the only requirement is that such data are fair, that is, accessible and interoperable, according to international standards such as the CRM. All kinds of such data will be considered: text, images, models, information about scientific analysis, and so on. We will establish correspondences between each individual metadata schema, that is the metadata schema of each repository, and ours, that is the HDT. We will include the metadata values, the original metadata values transformed into our schema in our system, but we will not move the content. So in this process called aggregation, we will not move terabytes of information, but only the small part which is formed by the metadata. When searching the knowledge base, this approach will enable cross-searching across sparse repositories, wherever they are, without moving them. Because the search will operate only on metadata, it will produce a result list with the metadata, and the user can then choose which ones are of interest and from them access the related data on demand. It is possible to update the data, to add new one, and this process is very economic because the new knowledge base includes only text, the metadata, but does not duplicate heavy datasets. For example, 3D models which remain with the owner, with the repository of the creator. So this works in this way. We start from external repository with data, metadata, and a metadata schema, possibly different from each other. So in the beginning we will consider only the metadata schema. Domain experts will establish correspondences between this metadata schema and our metadata schema, and we will be able to transform the set of the original metadata schemas into a new form which is organized according to the HDT, the Heritage Digital Twin, our metadata schema. And of course, they will bring with them the links to the data to which the original metadata referred. At the end, we'll include this new metadata content in our knowledge base. So we will be able to have a system organized according to our Heritage Digital Twin with the links to the original datasets which remain where they are. This procedure has been tested many times. For example, the Ariadne system collected in this way 4 million of archaeological datasets in Europe and is hosted by a relatively small computer system where the knowledge base is organized. The access to this knowledge base is free and open to everybody interested in archaeological research. How can be used the knowledge base? Apart from the use that we will discuss concerning specifically concerning the Artemis project, it is also a useful tool since the beginning because it can be used for study and research. If anybody is interested in studying work made on Carrara marbles, white ones, This can be done by searching the knowledge base, for example, with this condition, and accessing information on different heritage assets. The same can be done for what concerns conservation or restoration activities. So, in the knowledge base, all the information about work already done on heritage assets of different kind and different assets can be accessed and compared. With some extension of the system, also simulation can be carried out, and we will see in this presentation how this can be done. The system is also useful for valorization. So, for example, a virtual guide of a monument can collect valuable information from its digital twin, images as well, and 3D models and anything, to prepare a reliable and very well-based content collected from the knowledge base as far as this monument is concerned, but also others. So, for example, if the architect of a palace built in the past other palaces, this information will be available because there are the connections internal to the knowledge base which allow to access such information. So let's move on and add mobility to the heritage digital twin. So far we have seen how to deal with the static data. Let us see if it is possible to let them run. For this, we add three elements to the heritage digital twin: sensors, which collect information from the real world or from a simulation of it. They can also, of course, include actions by a human, and are a sort of window on reality. Deciders, they receive the input from sensors and take decisions about actions if necessary. It is a piece of software which processes the data and has internally some decision mechanism to act in the real world or to act on a simulation of the real world. Actual actions are made by an actuator. So if the decider allows action, it triggers the actuator triggers such action in the real world directly, really in the world, or operating on a local duplicate of the digital twin, a sort of digital twin of the digital twin. For example, if you want to simulate something, effect of an earthquake, we will not create an earthquake and destroy the real monument, but we will do this on a replica, a digital replica with a digital twin, actually, of it within our system. Here is an example. Rain, very strong rain, and the museum, and there are different inputs. One is the equipment indicated by the Red Cross, labeled IoT, Internet of Things, which is an instrument which measures the quantity of rain and other information about what is really happening around the museum. For example, there are also weather forecasts to be taken into account, and so we can get a simulation of what happens if the rain is very strong. What should we do to mitigate the adverse effects? if there is a risk of flood, for example, some objects contained in this museum can be moved up to the first floor, to the second floor, to avoid that they are damaged. Other actions may be undertaken, and the system can simulate the adverse effects of this rain, but also the results of our interventions. We must keep into account that the terms sensor and actuator should be understood in a very broad sense. So the sensors usually reports internally to the digital twin what is happening in the real world. But we must consider a sensor also the simulated actions that we want to carry out. So, for example, if you want to clean some marble with a specific substance, the sensor will collect the information from the knowledge base and report to you what happens if you use some substance instead of another, if you use some technique, for example, a laser technology to clean marbles, and you can actually see what happens on a digital replica of this marble statue, and avoid damaging it because some chemical is not appropriate for this cleaning operation. So the sensor is something which brings information from the real world into the digital twin, and the actuator is something that shows the effect of this action on a simulation, so another digital object, and possibly, if you authorize, also on the real thing, if you are happy with the outcome on the simulation. How does it work in practice? When there is a simulation, the system will create a local version, so as already mentioned, a digital twin of the digital twin. The digital twin will be, all the digital twins will be created close to the user in what is called an edge computing framework, duplicating the information to avoid continuously searching the system and collecting data from the repositories, because this is anti-economic. It will cause the transfer of plenty of data, very large data sets, and so it is more convenient to have locally a system which contains only the relevant information. Also, this is not only more economical, but also more efficient, because the transfer of big amounts of data can take time and create congestion on the network. So it is better to avoid this and collect all the relevant information in advance and make the data transfer once for all. So what is the project perspective? We will use the information stored in the system to simulate activities on heritage assets and test the results of such activities, performing them on a digital twin. As already repeatedly mentioned, we will have the original digital twin of the asset with actual information, and copies of digital twins which report, which include the effects of the simulated action that we want to test. Such digital twins changed by the operator's action can be saved and kept for future use, or just discarded. So if you are washing a painting with chlorhydric acid, you will probably damage it completely. Everybody knows it could be done by mistake in a simulation, and there is no use for keeping it. It was just your mistake, and so you can say, "Oh, stupid me! I made something which is completely irrelevant," and throw away the the digital result of this action. In other cases, it can be useful to keep instead the results for future use and store such results in the overall system, in the knowledge base. Keeping this will pave the way for further developments, and in the medium term, we will have a full digital library of efficient results, mistakes, which may help conservators and restorers in their professional work. So what we are expecting from the project? Of course, the final results are the ones I already mentioned, but to arrive to there, we must follow some steps. First thing is aggregate existing repositories of data and create an overarching knowledge base, organized according to the reactive heterogeneity paradigm. This will be continuing work. We will start, of course, with a pretty large number of such datasets, but it is planned to continually enlarge the knowledge base. Again, back to the Ariadne example, we started with maybe less than a million of archaeological datasets, and after 3 years of work, we have already more than 4 million of such datasets, because new datasets are added almost continuously to the system. Of course, integrating their metadata in the knowledge base of this project, which enables to have a even larger library as the one you see to my back, which is physical, but in our examples they are digital libraries, and continuously improve the effectiveness of such projects. As already mentioned, we will design the knowledge base within an edge cloud environment. After this test, we will have the possibility of improving the simulation, because we will know better, and so create better tools to analyze the effects of actions. This could be considered as just a research exercise. We want to test it on real cases, so we will create a number of selected pilots, preferably addressing as many cases of heritage conservation as possible, and we will demonstrate the above on these pilots. All the work will not be just a research exercise of a few computer people, but we will involve the communities, professional researchers, decision makers, and the public at large in the use of project results. For example, of course, professionals and researchers is obvious why, but also decision makers can appreciate the effects of doing something, of or not doing conservation for assets, because they will be able to see in the simulation what happens if the intervention is done, or if it is not done. These are examples of an initial set of pilots, which are as you can see, very different from Roman mosaics to historic palaces, medieval sculptures, and the forest, an ancient hydraulic system, and the current shape of a Renaissance village to simulate the effects of climate change. There will be more. This is an initial set of pilots, and more will be chosen and used for the simulation. All the system will be created what is called digital commons. Commons is a term which was born in the English word to indicate portion of land and natural resources shared and used by members of the community. For example, the inhabitants of a village had a common part of land where they could, which they could use for cultivation or for feeding their animals. The concept has been extended to the digital world. The example is Wikipedia, which is created by some experts or contributors in general, and it can be used by anybody because it is openly accessible. We will do the same or something similar with Artemis. Our results will be available to scholars, professionals, and any other community which is interested. For example, the knowledge base of Ariadne, the example I already mentioned, is free available. Anybody can go there, set search conditions, and access to results of such search. Access to services may instead may require a registration. So also this mechanism, free access, access with registrations, and restricted access will be designed by the project during its use. Of course, we cannot open input to anybody because we must guarantee that the data considered and used by Artemis are of the highest quality as possible. How we will define the access, and I would say also the maintenance and the future of the Artemis Digital Commons will be defined in the course of the project as part of its sustainability plan. Okay, so AI is nowadays in everything, and I want to express my opinion using a famous statement by Mark Twain, of course, adapted to our times. There are 4 kinds of lies: lies, damned lies, statistics, and the results of using AI. AI is, fits very well in this statement because it's just an extreme application of statistical methods. Don't be distracted by the terms which are just marketing terms. There is no intelligence behind. It's just statistics, very sophisticated statistics. And it happened with all statistics, it is very easy to misuse them. There is a famous example by an Italian writer. If I ate a chicken for dinner, well, you, and I don't, we have eaten half a chicken each. By then, I am still hungry. This shows that misuse of statistics can produce false results. Imagine what may happen with AI, which is much more powerful than just simply calculating a mean. In Artemis, we tested the use of large language models to improve the metadata of poorly encoded text. Imagine there is a paper written 10 years ago about something, and the metadata are very poor. So it would be very difficult to recover it, to find it in the knowledge base, because the metadata are not enough, just the title and the authors, and nothing concerning the content. Of course, we can hire people to add the metadata, but it is a time-consuming work, very tedious. Nobody wants to do that, and it's not immune from errors, because also humans can make errors. It is the typical kind of work which is better done by machines. And to avoid, as far as possible, such mistakes, we will educate the system and include in the statistics also semantic information, also information about the structure of the heritage digital twin. In some initial tests, we have discovered that this increases the reliability and produce a pretty satisfactory level in the test, pretty good results, and avoids almost completely what are called hallucinations, that is completely weird results generated by artificial intelligence. Additionally, in this example, the use of artificial intelligence for this purpose is completely safe. It does not produce problems, because we create new metadata using such large language models. If the system makes a mistake and adds a false positive that is pretends then the text concerns, let's say, a Renaissance monument, and instead it concerns Stonehenge, well, the user making the search will immediately recognize and they will be able to state, oh, this is a stupid artificial. It is artificial stupidity, not intelligence. And also, having this done by human is not immune from similar mistakes. False negatives, that is not discovering the connection, is harmless as well, because if artificial intelligence does not discover a connection, this something will be lost. But without using artificial intelligence, this connection will not be discovered as well. So, in other case, the importance of something is lost. So it is a win-win situation if artificial intelligence using large language models is used for improving the metadata concerning some assets. And last but not least, collaborations. So Artemis does not want to be a small patrol of high-level researchers. We want to work with others. First of all, with other researchers, so other projects, other initiatives which are compatible and can take part in an exchange of information and knowledge, integrating our results with theirs and mutual exchanging ideas. This will not be a patronizing approach. We are not going to talk to other projects and tell them, look how interesting is what we are doing. But instead, we will meet them and discuss and see if there can be an exchange of information, a reciprocal cross-fertilization. For example, we can collaborate and already have started to set up this. We project developing a similar or complementary data infrastructure. There are projects which consider events which are not included in the present version of the Hydra Digital Twin. We can be somehow connected to what we are doing and exchange research approaches and information. We are also interested in projects which address the quality requirements. For example, we were before I introduced the use of 3D models. Okay, but 3D models can be well done or very poor, and if they are poor, they may be misleading. So, projects addressing quality requirements for 3D models are highly recommended, and we can provide them what we need from the 3D models, so this can be also a part of their definition of different levels of quality. Last but absolutely not least is the collaboration with the restoration and conservation centers and experts. As already mentioned, we are not going to do this just for the sake of doing some interesting computer science research. This should be useful for people who do this work in reality. So restoration and conservation centers. We don't want to develop something which is purely theoretical. It has to be practically useful. For this, we have created an energy expert board with a number of world famous researchers coming from research conservation centers and conservation restoration research to get their feedback to be sure that what we are doing is not just an academic exercise, but it can be absolutely important for the world. Thank you very much for your attention, and I hope this has given you a understanding of why Artemis is there and how this can be useful to research and to the conservation and protection of our fragile cultural heritage.